Good day, folks. My name is Julio. I'm a PhD student from the University of Geneva in Switzerland, and I'm here to show you another video about lakes. Yeah, I know. You've seen a lot of things about lakes in the previous videos from my colleagues, but at this point, I'd like to show you some internal processes of the lake, how biology works with biology. I'd like to show you some food web interactions that are responsible for keeping the resilience of our ecosystems and the effects of losing biodiversity on resilience of lakes. So let's first draw our lake, which I would like to start with you from what we call the clear state of lake. I'm pretty sure that you have heard this term before from my colleagues, clear and turbid lakes. So clear lakes are inhabited by submerged aquatic plants, what we call macrophytes. The macrophytes inhabit the bottom of the lake and they compete for nutrients with algae, which is the food for the grazers. In our lake, obviously, we're gonna have some fish, not only because fish is a pretty cool animal, but because fish is a crucial part of what we call aquatic food web. Food web is nothing but the interaction between the organisms inside our lake. For instance, fish feeds from grazers, and the grazers feed from algae, while the algae competes for light and nutrients with macrophytes. Those interactions is what forms our food web, and our food web can be represented in the shape of a pyramid, what we call a food pyramid. Pretty simple, right? Does someone knows why is a food pyramid and not a food circle or a food square? That is actually due to the transfer of biomass energy from one trophic level to the trophic level just above it. In ecology, we know that those numbers are roughly about 10%. So if the base of the pyramid has 100, the next level will have 10 times less, so forth and so on. You might be asking yourself, why would that be important? I'm going to show you. Let's imagine that we have a heavy rainfall in the catchment, in the surrounding areas of the lake. And this rain is so strong that it starts to accumulate and to flush nutrients inside our lake. It might be in the form of fertilizers, or it could be sediment that's been carried inside the lake. You all have seen in the previous videos that lakes can be very sensitive to nutrient additions. Do you know why? Because the sun shines every day, and what limits plant growth is nutrient. Maybe not in Ireland, where you quite don't have sunshine as well, but that's another discussion. Let's come back to the scenario where we have light and nutrients. With these both things together, there's nothing limiting plant growth, and what we expect to see is a very steep growth of the bottom of the pyramid, which for us here is algae and macrophytes. If you have a biomass of 1,000 kilos of macrophytes and algae, how many kilos of grazers would we expect to have in our system? Remember, only a fraction of the biomass, the energy, is actually transferred from one level to another. So if we have 1,000 kilograms of algae and macrophytes, what we would expect to have is 100 kilos of grazers. And as you can see in this curve, it's not only that they grow to a lower tire, 10 times lower, but they grow slower as well. You see that the curve is not so steep as the green curve. That has an obvious reason. That is, you can't have more grazers if you don't have more algae. That would be inverting the pyramid. So we have to wait the algae to grow so the grazers have what to graze. In the last trophic level of our lake we have fish. Which level should we expect fish to grow? 10 times less than grazers and 100 times less than algae and microphytes. That's because only a fraction of the biomass can actually be transferred, right? But that's just part of the story. As I told you before, all those organisms that we have here in this lake, they interact with each other, and the fish eat the grazers eat the algae, and the algae responds to nutrient. So actually, what do we expect to see in our graphs here on this side is the effect of predation, and predation would bring the tires of biomass back down. Fish eat grazers and grazers eat algae, and that's why you see all those green and brown lines going downwards. And you might be asking yourself, and fish? Who eat fish? We all know that fish can be a very good food source for other animals, like for instance falcons, otters, or even some bigger wild animals like an alligator. It might be even the case that those animals that eat fish are eaten by someone else, like for instance this beautiful Brazilian panther. And that's what we call top-down regulation. The higher trophic levels, they regulate the amount of biomass, the amount of energy that contains in the lower levels of the pyramid. The panther eats the crocodile eats the otter eats the fish eats the grazers, and the grazers makes the amount of algae into the system never reach the maximum tire. The problem is that no one likes to live in the middle of panthers or to swim with crocodiles, although we kind of like otters, they're pretty cool, right? But if we have nothing regulating the amount of fish in our system, we break the balance of this top-down regulation, and actually the consequence is that algae manages to reach its maximum capacity inside the lake. It grows a lot. It grows to the point that the lake becomes extremely turbid. It grows to the point that the lake becomes green soup. That's one of the consequences that we may have due to the extinction of top predators in lakes. Lakes become much more susceptible to respond to nutrient inputs due to a rainfall, for instance, than they would be if they had all these trophic levels piled up. I'd like to stop this video here, but I will add you another link in the bottom where you can find actually what are the processes involved in the opposite of a top-down regulation, which is a bottom-up control of our system. So I'm going to show you in this other video what actually happens when the system is not regulated anymore by top predators, but actually by algae. Thanks folks, hope you have enjoyed it.